This is for Year 12 Specialists. It comes out of 9C, question 2F. And the question is really, why do some of the answers have restricted domains when there was no indication in the original that there was a restricted domain? So I've taken 2F as an example, and the question told me the first derivative in terms of y, so it was the square root of 9 minus y squared. And I'm told this, which means when x equals 0, y equals 3. And you'll notice that this is the first derivative, which means that's the gradient, and the gradient is positive. The gradient is positive because I only have the positive square root. Now this would tell me that y can only go from -3 to 3 because I can only take the square root of 0 and positive numbers. Okay, so if I perform my anti-differentiation, I flip this upside down, I integrate with respect to y, I get the inverse sine of y on 3, c will equal minus pi on 2, and since I have y equals 3 sine of x plus pi on 2, I can use the fact that the sine of x plus pi on 2 equals the cos of x. Therefore, there's my answer. And that looks like this. Now I know this point is on the curve because I'm told that y of 0 equals 3. So of my solution, this has to be part of the domain, and I know the gradients are positive. And these are the only values where I've got a positive gradient on my y equals. So I need to go from here to there. Since the period's 2 pi, that's going to be negative pi. So x has to go from minus pi to 0 for this to be the derivative. I could have here to here, however 0 to 3 has to be part of the solution. So it's the fact that the derivative was positive meant that I needed to restrict the domain, because in these many to one functions I have lots of restricted domains that have positive gradients.